So using the variables named training 1 through 4 and city. City is obviously a grouping variable, a nominal variable, if you will. I like the word categorical. And these look like repeated measures. And I'm assuming it is something about, let's read the question. Factorial ANOVA to determine if the training sessions were effective at increasing the number of new memberships. So that's probably a sales figure. After the first training, they measured their new memberships. After the second training, they measured their new memberships. But let's take a peek, shall we? All right, that's a grouper. And then we got our trainings. There's trainings, right? And these look like sales. So hopefully they went up, right? This guy went up. This guy went up. And so they all look like they're slowly going up. This guy not so much. So city is the grouping variable. And these are our 4 repeated measures. So the way I teach this thing, the repeated measures, you treat them like DVs. They're, some people say there's an IV time between them, which is true. But they're treated more like DVs than they are IVs. Okay, so let's get going. So we're going to run a mixed ANOVA. Some books call this a split file ANOVA, but it's when you have a between group variable, and in our case it's city. And then you have a repeated measures side to the test as well. So in other words, it's got between group differences, it's got within group differences, and they're all mixed into the same soup. But just remember, whenever you hear the word ANOVA, you're looking at differences of group means in something. So for ours, we're going to look at the group means in their sales for training 1, training 2, training 3, training 4. So in other words, they're going to have 4 different values that we're going to compare. And hopefully that the average of the trainings did increase. That's what we're looking for. So let's get going. First thing we're going to check for is normality. Yes, normality. So let's go check for normality. That's assumption number 1 for all ANOVAs and t-tests. We want to analyze descriptives up here off screen and explore, which is also off screen. I'm moving over the 4 training sessions. And we're going to get this so you can see it. Boom. And we just want the plots. We can look at the histograms, but again, histograms can be very misleading, but we're just going to check the math plots. And then we're going to click OK down here on the bottom. And survey says that's how many. There's 15 in each one. Not very big amount for an ANOVA. Remember, an ANOVA normally starts with 150 total. And we only got a total of 60. But, again, this is a learning video. So there's the means of the first one, second one, third one, fourth one. And here's our test. So, rule of thumb is if the sample size is less than 200, you're supposed to use the Shapiro-Wilk. And according to these guys, nobody violated the assumption of normality. Yay. And the Kolmogorov-Smirnov test is supposed to be if the sample is greater than 200, but it depends which book you read. But they agree. That's what I always look at, right? The sig values, the p-values agree. It says none of these were significantly violated. Analyze general linear model. This is not a univariate, right? That means 1 dV. Repeated measures. That's why I consider every repeated measures like its own dV, and it works for me. So we're going to put them in there. And I'm just going to call this training. Most people just put in time, which is the time between the training sessions. I could live with that, but it doesn't help me. And there were 4 of them we're going to add. And down here on the bottom, you got to hit define. We just bump them over. Okay, there's 1 through 4. Get over there. So, very important. This is a mixed ANOVA. Don't forget to put your grouping variable in here, your nominal variable. And for ours, it's city. Now we can click some buttons over here. I always start with options. We always want descriptives, effect size, and power. And homogeneity test, we're going to get an error on that because repeated measures doesn't check for homogeneity variance. It checks for sphericity, but there is a between group in there, so I just click it anyway. So the post hoc tests, I could stick the city in there, but I don't really want to do that at this point in time because it's going to get us a giant matrix, which is going to take too long. I'm trying to keep this to be a short video. But now I would like to see if there's a difference between the trainings. Now, you'll notice when I hit the post hoc test, trainings wasn't an option, but to do repeated measures post hoc test, they recently added this one, the estimated marginal means, and we stick in our training. Boom. Compare main effects, and then we tend to use the Bonferroni down here. Click OK. And let's see, we got the options, the means. We should probably put a plot in there. Let's do the training, and we'll do it by city. All right, that's going to be our separate lines. So we'll be able to see the change from training 1, training 2, training 3, training 4 for each of the cities. And whichever line has the steepest increase, that tells us who won there. And then we're going to hit the continue button down here off screen. I think that's it. Let's click OK and see what happens. While we investigate the output here, always keep in mind that you're looking for significant differences between the group means. So the means here are the 4 training means, right? The 4 repeated measures, the means of each of those measurements, and each of the 3 cities, right? So you got the 3 cities. Let's take Los Angeles. You're going to have a mean for training 1, 2, 3, 4. Another one, you're going to have let's take Atlanta. They're going to have a mean for training 1, 2, 3, 4. And for the other city, they're all going to be comparing the means to all 4 of these groups, right? So it's a big, giant checking the means to see if they're far enough away from each other to be called significant. So let's keep going. Okay, this tells you what your repeated measures are. Boom, 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 boom. Here's your grouping variable, right? LA, New York City, and Atlanta. And there's 5 in each group here. Again, sample size isn't the biggest in town, but what the heck. So this has the means, right? These are the means of their new sales. So this is training 1. This is after training 1. And it looks like Atlanta's the low guys down here. New York's the high. To be expected, right? New York City has got, what, like 1 billion people. So the bigger the city, probably the more sales. But they're looking for improvement, right? Keep that in mind. They're looking for improvement. And then here's training 2, 3, 4, and these are all the means. So what I always do is I look at the first one. So 101, 151, 98. And they all went up here, right? They all increase. So let's see if it's significant. All right, next box. This is your test of normality. I'm sorry, your homogeneity variance for all your covariants as well. So the sig value, this is called the box is M, and we're going to get a Levine's test down here that should agree with this. But your box is M, that sig value has to be less than 0.001 to be violated. So that's the one test that I know of where if it's less than 0.05 isn't good enough. Again, I'll say that again. If the box is M, if the sig value is less than 0.001, that means it violated the assumption of homogeneity of variance, and covariance is more than likely one of the covariances in there. But let's keep looking. So here is your multivariate box. Very important. But I tend not to use this here. When you write up your dissertation, yeah, you would write up something from like the Wilks Lambda, or we tend to use the Blaze trace down here, but it's up to you. But now this will tell us that, yeah, there's a significant difference between the 4 repeated measures, the 4 training sessions. And down here, it'll tell us, yep, there was a significant interaction. In other words, one of the cities did much better than the other cities when it comes to the increases over the 4 training periods. But let's keep going. Scrolling. This is our check for sphericity. This is our Mauchly's test. And Chongo, it did violate the assumption. In other words, the changes from training 1, 2, 3, 4 were not systematic. In other words, we would like to see all 3 cities show the same increase over the same number of trainings, but that did not happen. So we're going to have to use one of the corrections here. It's called error correction. And either the Greenhouse, Huntfeld. we tend to use the Hunfeld because it gives you the biggest number. See that? It's very nice to us. But we're just remember that it did violate this sphericity. And so this is the box that we tend to use down here. So this first one is, was there a significant difference between the 4 trainings? And it says, yes, there was. And there's your app score and your degrees of freedom. And here's your interaction. In other words, did one of the cities do significantly higher or lower than the other 2? And that is saying, yes, that is the case. So let's keep looking down. This is the contrast. Basically tells you which approach should you use, right? Is the data fit a linear curve, a quadratic curve, or a cubic curve? And you'll notice that the strongest one is linear. And so that kind of backs up the reason why we used a linear equation here and not a quadratic or a cubic, thank God. So let's keep going. Levine's test. And again, you'll notice that this did agree with the box's M test from above. Nobody violated the assumption of homogeneity training, homogeneity variance. And this is your between group, which we kind of already know is significant, right? That told us back in the upper box when you had an interaction between the 4 repeated measures in the cities. So this is kind of a repeat measure here. And estimated marginal means, getting to the end of it here. Oh, and this is the pairwise comparisons for the trainings, right? 1, 2, 3, 4. I love the Marine Corps. So training number 1 had a significant difference between training 2, training 3, training 4, and you'll see everybody's significantly different. Makes it easy. Multivariate test, the rest of this stuff. Okay, here's your repeated measures. 1, 2, 3, 4. So as a whole, everybody did go up, right? These are averages. And then by city, it should be right here. Yeah, here's the one by city. And I don't know how to make this smaller, so I apologize. But so this one looks like New York City, right? They had the biggest sales. They started out here, ended up here. So they did a pretty good increase. And let's look at the blue one. That's this one, right? They did not increase that much, right? They went up a little bit. But I'm looking at the red one. That has to be Atlanta. That went up the highest, right? It started under 100 and it ended a little bit over 120. So that's quite an increase there. The increase for the Los Angeles guys wasn't that much, like 110 up to 117 or something. So it only went up about 7,000. But for the Atlantinians, you'll notice they went up over 20, 21, 22, something like that. And then the New Yorkers starts at about roughly 152, and it goes up to like 162 maybe. So the New York guys did go up, right? So, but I'm pretty sure the winner was Atlanta. But now let's go back and answer all the questions. All right, we already checked for normality, not a problem. Let's check for outliers. There are many ways to check for outliers. I'm just going to check the box plot here. It'll give you a pretty good idea if there are any outliers. And I got you in here somewhere. Where are you? I know you're in here somewhere. There you are, boom. And it's so no outliers in training 4. None in 3. A little bit skewed. None in 2. Same thing, a little bit skewed. And then none in 1. Okay, so no outliers. Back to you. And there's the test of normality, homogeneity variance, right? The trainings, they all basically had a clean bill of health for the variance rule. And the boxes M also agreed with this, so we could put either one of those up there. So I'm just put the Levine's test because that's what I'm used to. Okay, so next step. Was the team building training effective overall at increasing new membership? So that's just the repeated measures. So that's this, just the repeated measures. That's this first box. And it was, right, there was your sig value. And it tells me it was an older version for some reason. It should have been less than 0.001, but just keep that in mind. So the answer is yes. And that's how you write it up. Huge effect size. Right, this effect size, if you saw this in real life, 8.896, you should be suspicious. Because that's way high. But again, I just made these numbers up. Next question. Was there a significant difference between the cities? There are new memberships between the cities. So yeah, that's your between group side. So that was that one box that we had down there at the bottom. And there's your ANOVA. Don't look at the intercept, you guys. It's always the wrong one. Look at the group. So the group is 0.011, which is less than 0.05, which was, there was a significant difference between the cities. But that's just an overall difference. That doesn't do it by the individual trainings. And this is where the money box is. Was there an interaction? Heck yeah, there was an interaction between the repeated measures and the group. That's what this is. So sphericity assumed. It's not assumed, right? It violated sphericity. So we're going to go ahead and probably use this one. But you'll notice the sig values are all under 0.05. So it really doesn't make a big deal which one of these you pick. Different researchers like different ones. But again, we like the Hunfeld because it's the nicest towards us. And then, which city showed the most increase in the training? Again, I looked at the graph. Where's the graph? Hold on, let's go look at that graph. This one. Whoever had the biggest change between training 1 and training 4, and it's obvious to me that it is the Atlanteans, right? They changed the most. They went up over 20,000. So the training worked best for Atlanta. Okay, so this is how you would write it up. I'm not going to read it to you. Just leave it on screen. You can freeze it if you want. Blah, 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 blah. And then again, there's the normality, independence of observation. There's no way to verify that in the ANOVA or the t-test. We just assume it wasn't violated. Homogeneity variance again. Assumption of sphericity was violated. Right, so we use the Hunfeld here. The Mauchly's test tells it was violated. And I'm going to put some links in there if you guys forget what sphericity is here. But this is how you will write it up. And I put a little nice note there. If you ever notice decimals in the degrees of freedom, that tells us that the data violated something. And in this case, it's sphericity. So always keep that in mind. And there's that to write that up. And here's a whole write-up on the whole chimichanga. Again, I'm not going to read it to you. But I will slowly scroll. Data, data, data. Boy, do I love data. And oh, there's our plots there. Same thing. So I wish they made the colors a little bit different. But the biggest change from training 1, training 4 was Atlanta. And I think that's about it. Okay, so here's the video, and I hope it helps. MJZ.